Looking at sequence series, a sequence is an ordered list of numbers. The numbers in the sequence are called terms. If the sequence is arithmetic, the difference between consecutive terms is constant, and that's what we're going to look at. The constant difference is called the common difference, and is denoted by D. So we're going to take a look. In this one, we're going from -4 to 1, so a difference of 5. We're going from 5 to 6, or 1 to 6 rather, so a difference of 5. 6 to 11, difference of 5. All of those differences are the same. It's common. We have an arithmetic sequence. So this one, ready to go. Over here, we're going from 3 to 5, 5 to 9. You'll notice +2, +4, +6. This difference is changing. It makes it a non-arithmetic sequence, right? Because that difference is not constant, not arithmetic. Down here, we're going to take this and we're going to write a rule for it. Now this looks scary, but it's really not so bad. You've got an arithmetic sequence. It's got this form. You start off with your number, all right? And you've got that change that you're using. In this case, it was a +5. Everything gets a +5. So this is your very first term. This is where you start. You need to know where you start. Once you start, I know that I'm going to add that change one time. That's the next number. That's number 2. I'm going to add that change again. So I've added it once to get here. I add it twice to get to that third number. All right, so start here, add that 5, add another 5, and we add another 5. So it'll be 3D, and then 4D, and then 5D. So it gives us this formula. If you want to find the value of any number in the series, you take that first number, and then you add to it a certain number of that change. So example, if I wanted the third term, I would add that change twice. Because you start here, here's the first time you add it, here's the second time you add it. So you take 3 minus 1, I'm adding it twice, and multiply it by 5. So we're going to take the rule above, we're going to find A of 100, all right, the amount of 100. So I'm going to start at -4. I know my difference is 5. My rule, again, starting at -4, I'm going to add to it a certain number of 5s, a certain number of changes. Well, I want the 100th term. That means I'm going to add 99 5s to -4. So I've got -4 plus 495. Add that -4, I'm going to get 491. That's it. The sum of the first n terms in the arithmetic sequence can be found using this formula. So I've got the sum is equal to the average of the first and the last terms times the number of terms that you're doing. All right? So you take the first and last terms, you add them together, you divide that by 2, and that will give you the average value for all the terms. If you take the average value and multiply it by the number of terms, you get the total sum. Not so bad. Continuing. So the sum of the first 100 terms, looking for the sum of the first 100 terms, it's equal to 100. I know that the value of my first term is -4. We're still using that series. I know the value of my 100th term is 491. And we're going to divide that by 2. So again, we're just following the formula. We want the average value of the terms, and then we just multiply that by the number of terms. We got the sum. So I'll get S of 100 is equal to 100 times 487 over 2. I'm going to have to grab a calculator, and then I'm going to get 50 times 487. Get that punched out real quick. 50 times 487. And that'll give me the sum of 100 terms is equal to 24,350. Boom. Looks just like that. All right, next one. Real world applications. Jennifer starts a job with a starting salary of $25,000. She is guaranteed a raise of $1,500 for the first 4 years. So again, when we go back to this formula, all right, it's just, we start out at a certain number, and then we add that difference for every number past that one. That's why we have the n minus 1. As an example, we start out with $25,000, and she's going to get a raise of $1,500. But she doesn't get this raise the first year. In her 5th year, she will get a 4th raise. So we take away that 1 because the first year you don't get a raise for that first year of employment. You get a raise for year 2, year 3, year 4, and year 5. All right? So we're going to take $25,000 and we're going to add $6,000 to it. So she'll be at $31,000. All right? Find her total compensation. So again, we're going to find the average she was paid. So her last year, she made $31,000. Her first year, she made $25,000. Since her raising was constant, if I find the average of this and multiply it by the number of years, then I can find out how much she made. So this will give me the average. And let's punch that out. 31,000 plus 25,000 is 56 divided by 2. So she made she made an average of $28,000 a year. This is what she averaged each year. If we take that and multiply it by 5, it will give us the total. And she made $140,000 over that 5-year period. All right? And that's how it works. That's how the sequence works. Make sure that you write all of this down. I cannot stress enough how important that will become to you later. All right. In a geometric sequence, you've got a ratio of any term to the previous term is going to be constant. This ratio is called a common ratio. Basically, you are multiplying by a given number over and over again. So how do we multiply? To get from 3 to 6, we multiply by 2. To get from 6 to 9, we multiply by 1.5. You'll notice this is an arithmetic sequence. This is plus 3, plus 3, plus 3, plus 3. We're not multiplying by a number. We're adding a number. This one, how do we get from 128 to 64? We multiply by 1 over 2. How do we get from 64 to 32? We multiply by 1 over 2. How do we get from 32 to 16? We multiply by 1 over 2. This one is going to be geometric because we've got a constant ratio. We're multiplying by the same number each time. Just like the last one, we're going to take that rate that we're changing by, in this case 1 over 2, and we are going to find out how many times we're going to multiply that rate in. Because again, we don't multiply it on the first term. We multiply it on all the terms after that. So example, if we're looking for the 10th term, I'm going to multiply my starting value by 1/2 9 times. That's why we have the n minus 1. So find the rule. We'll have A1 is 128. And then we have the rate, which is 1/2. And we are going to multiply by 1/2 however many times we need to. This is our formula. We need to use it to find A10. So for the 10th term, I have 128. And I'm going to multiply it by 1/2 9 times. So I'm going to take my calculator here, and I'm going to go 128 times 1/2 raised to the 9th power. And it's going to give me 1/4. So A10 is equal to 1 over 4. We're going to cut the video here.